Morning everyone, our report is about the smart grid. So as an overview, the grid is a network of power lines that carry electricity to businesses and homes. The smart grid is currently running at full capacity and issues may occur. In order for us to detect faults, we put sensors along the grid to easily determine and pinpoint where is the issue have been occurrence. So here, if a tree falls, the conventional smart grid requires a person to manually reroute the electricity, which requires time. And on the other hand, the smart grid only uses sensors to reroute the traffic, which has lesser response time. And also, electricity varies in the different kind of day, the prices. So through the smart meters, we will be able to use our appliances in which time so that we could reduce our energy bill. And also, smart grids uses different sources of energy which stabilizes the grid itself. And also, it would mean that we will require less burning of fossil fuels in the future. So the next slide would be Dennis.
Yeah. Thank you, Lothar. So we will now go into deeper of the components of a smart grid. But to note, the components we'll be mentioning to you will be more on what is current, but the directions in the future, I'm more excited to talk about that in a while, or Lothar also. So obviously, we would be needing energy storage systems for the electricity consumption in real time. But mind you, for energy storage systems, it's not also going to that direction in the future. I will tell you about that later. And no more details about this because this is very basic that we will be needing gateways, routers, and the like in our entire infrastructure of a smart grid. So unlike other IoTs that we've been talking about a while ago, this is more on a grander scale, like even across countries, because there are power plants involved, and obviously there are other suppliers also into the picture. Okay. Now, next to that would be, of course, I'll show you an example of an energy storage system or an ESS. Then the IoT devices that would be needing smart meters, actuators, sensors, and smart transformers. We will be detailing to you each of those. First, we will start with smart meters. Allow me to tell you that in the Philippines, we don't have smart meters. So somebody goes to house and to check the meter of how much we have consumed every month. And there will be another person going house to house to give you the bill. I mean, what do you call what's called that? I think it's called the bill, right? So with the smart meters being used currently in some other countries and even here in Canada, we will have smart meters to our homes that will be directly connected to the cloud, and immediately, of course, a system where the supplier would be computing that in a system and giving you directly how much you will be paying. Okay. So Lothar will now be talking about the sensors.
So we cannot call something smart if we don't have any sensors of our actuators. So sensors, as we all know, there are various types of sensors. We have temperature, humidity, and voltage, and etc. So here in the smart grid sensors, we use the voltage sensors, phasor, fault detection, and temperature thermal sensors. In here, the voltage and current sensors, we use the Rogowski coils or the Hall effect sensors. So the Rogowski coils measures the electricity through a coil. Just imagine yourself sitting beside the beach. So the waves will be measured through how it changes, but not how frequent it comes. So this device is pretty useful because you can easily measure how much electricity is flowing along the line. And also here, the phasor, provides synchronized real-time measurement of voltage, improve grid stability, and use for wide area monitoring. So basically, all the sensors are working in tandem so that they could provide easier monitoring. So also fault detection and location sensors. We have the smart line sensors and ground fault sensors. This one, smart line sensors, detects everything. the voltages, the current, and also the loads. So, and also here the temperature and thermal sensors. By the name itself, it measures the temperature and thermal sensor, so that if ever a line or a transformer heats up, it could easily prevent any explosion or any outage in the area.
Now, we'll go to our actuators. We have some breakers and reclosers. Here are some pictures of those. They will automatically disconnect and reconnect power in case of faults or the rerouting that we've been talking about a while ago. Also, we have load tap changers or LTCs. This one is actually inside this one. It's a big component. It will adjust the transformer to maintain the voltage levels, because as you know, I don't know if you know this, supply of electricity is generally all over the world not stored. So once it is not used, it will be gone, right? So by doing this voltage regulation, there will be no overload and no more outage. I'm so happy in Canada. Since I was here, there was only one. How do you call it here? We call it brownout in the Philippines. Blackout. It's named. I don't know why it's called brownout there. So there was only one day I experienced that. But in the Philippines, it's every weekend, every Saturday or every Sunday from 8 to 5 p.m. So by doing this, there will be no overload and no. So meaning it would the will be level. Okay. Then we have capacitor bank controllers, which will be which will switch capacitors in and out of the circuit to optimize power factor. So originally, power plants were using DC during the time of Thomas Edison. Now we're using AC more frequently, but because of the use of other green energy, we went back together with AC. Now we have also DC also. Okay. So next to this would be here's a sample of the transformer, because it's a very important component. I've been looking at this picture for quite some time. Then I was checking a lot of materials over the internet, and this was where I was excited. I saw one of the main players of smart grids now, which is Denmark, where the ultimate goal of the future will be each household will be a supplier in itself. Meaning, for example, our cars is, for example, powered by electricity, right? But since most of the time cars that are on standby are not in use, and electricity is not in use, and there is battery there, meaning there is storage. So once you plug the car, if the entire smart grid knows that there's more supply needed in a certain area, the car will be the same supplier going back to wherever it wants to use. And obviously the house can also be a storage in itself and supply to other need clients. So that is the direction of the future, where the house in itself, either by panels or even by storage, there is what you call an HCU, if I'm correct. There's an but it's a component, it's a hydrogen being in the house as like a battery, where it can be the supply also to other houses and to other corporate entities in the area. Because the idea of this, if you see it going back and forth, because that's the idea of also of AC, is to make every component in itself react to the needs of wherever it is, so that we will pull down the cost of electricity. Just like when, for example, if there's too much wind, like for example in Denmark, they have a lot of windmills. If there's so much wind, then therefore the actuators and the controllers will shift going to the wind supply of electricity rather than the usual either biofuel or either the coal power plants, which we want to eliminate in the future. Right? So we have now Lothar.
So here we have the standards for IoT for the communications. So this one is the International Electrotechnical Commission. These are the commission that is responsible for the smart grids. So this one is mainly a standard for communication itself. and this one is responsible for the secure data communication. So these two standards goes hand in hand in order to have safer and smarter grids. So here we have the IEEE 2030. So this one is more focused on interoperability of the grids. For example, if we have grids from other suppliers, they will be able to easily interoperate themselves. So next one. So here, why IEC standards matter for smart grids. So here, as what I mentioned in the previous slide, so interoperability, so reliability and efficiency, so ensures stable and optimized energy distribution. Cybersecurity, yeah, the most important part today because everything is on the internet. So also future proofing. So it means that moving forwards, it will be easily to improve things and supports new technologies like IoT, AI, and renewable integration. So here, as what we have mentioned here in the class, also in the lecture, we have the protocols. We all know the Zigbee, the LoRaWAN, and especially the MQTT itself. So these are the communicating protocols that is used in the smart grid. So DLMS or COSIM, so standards for smart meter data exchange and communication. So this one is used in the smart meters so that the meters will send the data directly into the central office. So here IPv6/6 low pan. So this one is a new technology. So in the future, everything will run in IPv6/6 low pan.
Now, to put it into a summarized perspective, there will be first the creation, the collection, then manage, then utilize. So in the old system where most of the world is still doing things is I think is more on the creating and supplying only. There's not much about managing, and of course not much about how to utilize it. So this is the direction of the future, which is about smart grids. And if you will see there, sensors will use data and the decision, because the money is very important here, especially for us consumers, where electricity is very, very expensive. So if we will know, as you've seen from the video where Lothar was talking about, we would know, if we would know when will be the electricity will cost low, that's the time we can automatically through our smartphones control how our washing machines, our appliances in our house, in our smart house, to turn it on, like when we're asleep. So it's scheduled to do that when our electricity is not expensive. And then so basically these are some of the components. You will see the colors there. We have blue, green, black, and green, and this will interplay in itself, as I've mentioned already a while ago. And the challenges, I'd like to obviously highlight one thing only, if you can just read through the slide. But the biggest challenge, because it's connected to the internet, it's cybersecurity, where there will be a bigger impact if somebody hacks the system, right? So, but obviously everything is in threat today because of the internet. So these challenges are in a way normal, but with a lot of effects to us, especially if somebody mess up the smart grid, right? So that's one big challenge for our smart grids that they are studying now, to make it more secure. So one last component that we would like to mention is the edge computing versus cloud computing, or a hybrid. So all of these have pros and cons, and I think we know why. So we need to understand the balance of those things as we go to using our smart grids already. So why we need to? Because we are going to the direction, as I've said, being us both consumers and provider. The term there now is prosumers. That's the new term now, prosumers. Okay, so we becoming consumer, both consumer and provider. So I think this is the last slide that we are doing. IoT and smart grids powering the future, smarter, more efficient, more sustainable. There will be real-time monitoring, and a lot of innovations. Together, we build a more connected and resilient energy ecosystems. Thank you so much.